Okay, guys, we're talking about auxiliary views. So let's take a look here. Under our class notes, I have a chapter on auxiliary views for you to read. I'm just going to go through it here, hit the highlights. So basically, an auxiliary view, let's look at it this way. Not everything is a nice square, right? Not everything can fit perfectly in 3-view drawing. So let's take a look at this right here. I'm talking about this right here. We have this shape right here. It's at an angle on the top view, as you can see. If we did a true front view, right side view, and top view, okay, we have true shape here of this square shape, right? Down here, unfortunately, on the front view, we have an oblique surface. And then on this right side view, we have an oblique surface. And one of our primary things, one of the most important things, rules that we have is to show, when we dimension these things, show the true shape and true size. Well, we don't have a true shape or a true size of that particular surface right here. So what we do is we create an auxiliary view, okay? And what we have here is a view that comes off of this particular true edge right here. This edge is true. This is a true shape of that top. And this edge is true. So if we project the plane off of this edge, we can get a true shape of right here. Now, this is all we need at this point, okay? We don't need this thickness is shown here, okay? The length of the object or the width of the object is shown here. The depth of the object is shown here. The height of the object is shown here. Okay, so these two views are pretty much unnecessary. We come down with one auxiliary view, and we can show that object completely. So, you know how we talked about the glass box, right? You would have your front view, your top view, and then your right side view. Well, in this situation, instead of using a right side view, they put a plane that's parallel to this oblique surface and create a new plane. Okay, that's an auxiliary view. Now, when you get into descriptive geometry, and we're not going to do that, but just to give you some theory here, creating these things, we have our planes. Okay, these lines that represent our planes, our top plane, our horizontal plane, or side plane, or whichever. And if you connect the dots here, okay, the distance from the plane, okay, so if I come here to here to here to here to here, I got all these, I got this plane right here. Okay, if I measure this distance, okay, this x distance from here to here, it's going to be the same from here to here. And likewise, from here to here, from here to here. So this x distance is the same, and I can create this view. And it's all perpendicular to the plane that I want to project off of. There you go, this kind of shows. So this can be very useful. Now, there's primary auxiliary views and there's secondary auxiliary views. Primary auxiliary views are auxiliary views that come off of the primary plane, one of the primary planes. Like this is the primary plane, the frontal plane, the horizontal plane, and the profile plane, which would be over on the side, right? So any view that comes off of one of the primary planes is considered a primary auxiliary view, okay? So that's what we have here. We have this view, for example, here is coming off of the frontal plane. So that is a primary auxiliary view. There's also secondary auxiliary views, which we will not deal with in this class. A secondary auxiliary view comes off of a primary auxiliary view, and so forth and so forth. So in this case, we do draw the front, top, and side view, but we still don't have this information because this is oblique here and this is oblique here. we need this information, we need this information, we need this information, and we also need this information. So we end up with 4 views in this drawing. Let's see. Yeah, these are just different. That's a depth auxiliary view. Here's a height auxiliary view. When we're coming off of the top view to get this information. In this case, a side view is going to be unnecessary. This is a width auxiliary view. We have this view here, side view, and then we come off of there to get. How did they do that? So we have this, that. That was a little confusing. Yeah, we get this information. We've got our front information. We got this information. What are we gonna? Oh, we're getting this right here. Yeah, I see. Okay. So just different ideas. You can read through all this stuff. I'm just giving you the basics here. This right here is an exercise. Okay. That you would do in descriptive geometry, which we are not going to do, and that's where you take an object and you just shoot lines of sight from all angles and get as many auxiliary views as you can. It's just to tone up your skills in creating auxiliary views, and you can go on and on and on and on. We used to do that in our board drawing 2, or our advanced board drawing course. But we don't do it anymore. CAD has really kind of simplified a lot of things for us, but it really is good to know. Okay, here's an example of that. See this? Take this drawing and you just take all these lines of sight, make this view, then transfer it to that view, to that view, to that view. Pretty cool stuff. All right, hold on. Excuse me for a second. I have to deal with a. Okay, taken care of. All right, and this is an example of a secondary auxiliary view, which we will not do, but let me just show you what it is. Excuse me. This is a situation where you have, not only do you have an angle here, but you have an angle here. Okay. So in this case, and this is a little confusing, but they started with this front view, and then went to the front and the top view. Okay, so they got this information accurate, and they got this information, which actually they can get elsewhere, but then they transfer to get the dihedral angle. The dihedral angle is, this is a true length line that is common with this plane and this plane. Okay, so if you were to transfer projection from this viewpoint right here, you get a point, which is going to this true length line turns into a point, right? And every line off of this point, okay, gives us a true angle. Now these lines are both going to be oblique. They're going to be foreshortened because this isn't the true length of this. It's oblique to that, and this is oblique to that. But from here, we can transfer up here and get this, make the lines perpendicular to this surface, right? This is what we're after, perpendicular to this surface right here, and we get a true shape of this surface. So you get this true shape and this true shape, and then whichever one of these you want to use, probably this one would be the best one to use for this thickness. Okay, so that's how that works. And then this view right here would actually be kind of pointless. Get rid of that one. But there's our auxiliary, our second auxiliary, front view, top view. We have the true surface of true size of this surface, and we have a true size of this surface. That can get complicated, but I digress. Back to primary auxiliary views. Let's see here. You can read through all this stuff. This is basically how to draw stuff, and I'm going to go through one with you. And this is more creating auxiliary views. All right, here we go. Well, here's one thing about circles and ellipses with auxiliary views. Circles, when they become oblique, become ellipses, and sometimes you have to start with the auxiliary view first and then work your way back to find the ellipse shape in the primary view. So you can start your primary views, like say this top front and top view, and then this side view, right? And then create this, because we know its location and we can draw the true shape, but we don't know exactly how to draw these parts, these elliptical parts. So we can use this to transfer back to here to draw this, and from here to here to draw that. So hidden lines and auxiliary, we're not going to do anything like this right now. Maybe, I don't know, sort of. I'll show you. Okay, hidden lines and auxiliary views. They are like, this is an auxiliary view right here of this surface right here. Okay, so these hidden lines, we take them out. Okay, we just don't bother with them. In fact, we can cut a lot of stuff out. Like in this drawing, we're going to do a drawing very similar to this. I really don't even think you need this part, but I mean, you can throw it in there. It looks good. This actually should have a view up here too. You need this. You need what's going on down there, and that's important. Okay, you can read through that. Partial auxiliary views. Okay, so here's a situation where you have this object here, right? If you were to show the top view, okay, you would get a lot of stuff like this information that will be oblique, and it doesn't tell you much. So you just draw this much of it. Okay, the right side view. If you were to transfer the whole right side view over, you get all this information, and it would be oblique, and it doesn't really tell you anything, so don't draw it. And then the auxiliary view coming off here to show us this information, everything that would come underneath of it. It's really unnecessary, so you can break that. Just draw the important stuff. So you got this, you got this, you got this, and this right here, and that tells you what the thing looks like. Likewise, over here we have our top view and our partial front view, because if we were to continue to draw this, it would all be foreshortened and oblique, and it doesn't give us any real good information. So we have room now to put our auxiliary view from the top view right here. Okay. So we have a front view and a right side view of this object, and we have a partial auxiliary view here and a partial bottom view, because this stuff is just, it's not necessary. Here is more partial auxiliary views. This is common when you have a part like this. It's like this flange here, and these are different, okay, but they're also symmetrical. They're rounded, right? So you could draw the whole circular area, but you're going to take up a lot of paper space. So you can just do a half auxiliary view of this area and a half auxiliary view of this area plus this, and you got everything. Okay, reverse construction. This is kind of like what I was talking about earlier. In this one, you got the front view and the right side view. Well, to draw the right side view, to know where this stuff is, you can know where the top is and where the top of this is by projecting these points across. But you really don't have the correct information to draw it properly. So you can go ahead and draw your auxiliary view off of the front view and get all this information, then transfer this information back to here as to where that tangent point's going to be and where this tangent point right here is going to be, to create that. Auxiliary sections. So here's a situation where we put a section on auxiliary view. So you could do a cutting plane line at an angle to show a section for whatever purpose that might serve. I'm not exactly sure why they're doing one here, but there it is. Cut through, and there's the auxiliary of that section. Okay. Here's a secondary auxiliary view. We really don't want to deal with this stuff. Here's an auxiliary section. There's like a part right here. You want to show the shape of this kind of like webbed area, and you can't see it in the front view. You can't see it in the side view, and you don't get it in the top view. So you can do a cutting plane line at the auxiliary angle, which will be 90 degrees to these lines here, transfer it up, and then you can have that right there to show you what that looks like in there. And then you can put dimensions on it. All right. Viewing plane lines. They look alike. They look like cutting plane lines. We've talked about viewing plane lines before. They're well, let's see here. When there's too much going on, okay, this is what viewing plane lines aren't always necessary for auxiliary views, but if there's too much going on, okay, in the drawing, and this is really a poor example, but there's too much going on in the drawing, and you can't show a true projection, which this one does. Okay, you can't show a true projection, like have it exactly in the right spot, and say you have to move it over here or something. Then you put a viewing plane line in, and you label it, and then so you can label the view that this view is what that is, looking at it from that direction. Yeah, we're going to do something very similar to this, and like I said, we really don't need. Okay, so let's take a look at the assignments here. Also, well, let me show you some other stuff real quick. Alright, so there's also a video under standard drafting concepts here. That's very good. That probably might give you a little more rational or less scattered explanation than I just did. It's one of these old videos, but as always, they're excellent. You know, it kind of shows you how that whole concept runs. Let's see here. There you go. Drawing your auxiliary views, and up with the with the glass box and everything. Like this is a perfect example of using auxiliary views to open that up a little bit. Full screen's unavailable. You jerk. Guess I gotta go to YouTube to do that. That's all right. You can see. So here we have the front view that's broken right here, and these lines here are just construction lines. But anyway, you come up with this. You can get rid of these lines because they're just construction lines. And then you can dimension that. But that's a pretty good video right there. See, there's another one where using the broken views. Okay. You have this view, you have your front view and your side view. Top view isn't going to give you any information. If you had a true top view here, you would have an oblique view of this surface, and that's about it. So anyway, so our assignments are right here. There's two of them. One's metric, one's English, and I'm going to go ahead and do those and post those. Okay.